I really think that this work has a lot of interesting applications and a potential for human health. I think this sets the standard in the field of we no longer require expensive technology inside of the clinic to get quality healthcare. And this type of technology that can be integrated into your everyday clothing and just be bought at a drugstore or in a department store can really enhance the human experience and have patients get good quality health both inside and outside of the clinic.
This is an NSF-funded project to improve the resolution of wearable capacitive sensors. So capacitive sensors are the kinds of sensors that your phone touchscreen uses, but we're integrating them into wearable devices and then trying to improve their accuracy in wearable systems by combining multiple different kinds of sensors and new sensor construction. We're hoping to accomplish our goals by using a combination of newer sensor types of construction and then the way we lay out the wearable capacitive sensors, as well as sensor fusion, combining inertial sensors to self-correct some of the inaccuracies of wearable capacitive sensors, and then using super resolution, which is an artificial intelligence technique, to better interpolate between sensor data by using either historical data or other kinds of sensor data to infer slight differences to improve the resolution. I think the long-term impact of this project, in addition to what we hope to be able to do within precision rehabilitation, is also the impact on these individual students who are learning novel artificial intelligence techniques to be able to interact with human-computer interaction and be able to understand how we move, how we interact with things, and how people can better work with digital systems. And I think the students who are on this project are gaining an appreciation for human-computer interaction in a way that they probably would not otherwise through their normal curriculum.
So basically, in essence, the work I'm doing is I'm trying to create a wearable sleeve based on capacitive sensors, and that is basically going to enable us to track rehabilitation for people with strokes and ischemic attacks. And we're trying to bring technology and embedded systems closer to the human experience, so it's no longer in the clinic, we can take it out of the clinic. So my goal is to create a sleeve that hides all the electronics but has all of the electronics and wires in it, where you can immediately just wear it and it's like a garment you can go buy at the store. And that's like the end goal of this, to create a wearable e-textile, a smart sleeve that can basically connect to your phone and talk back to you as you're moving and give you feedback on any motions that you make.
So I'm applying super resolution technique. It takes low resolution data and it converts it into a high resolution data. So with the help of super resolution, I don't need more expensive hardware things. I can use the low cost sensor and increase the resolution and see how much more data and detailed information I can get from low resolution data. I'm hoping in the larger sense it will be more impactful, because it will help in rehabilitation systems, so that might be helpful for the stroke survivors.
I'm taking a capacitive sensor array that was created by a previous PhD student and improving upon it by increasing the resolution on it, by adding more rows of capacitive sensors. So like with a computer screen, the higher resolution you have, the more pixels you have. The same concept applies to this capacitive sensor array, so I'm trying to increase the number of rows of capacitor sensors so that there are basically just more pixels on the array, and that will give us a higher resolution of data for the work that we want to do. Instead of 8x8, it's now a 16x16. With the 8x8, it's controlled by one microcontroller. Now that it's a 16x16, there's basically 4 grids, and each grid is an 8x8. So each grid is controlled by a microcontroller now. So the 4 microcontrollers control each 8x8 that makes up the 16x16, and then they talk to a master device
My project revolves around decentralizing mobile apps, and more specifically for the overall project, I will be taking data from Abhinav and both storing it in a pod for one version by taking the data from Bluetooth that he sends me from his board, and then the other version is to just receive data from the pod and visualize that in the app to show it in graphs and basically kind of show the user the movement that they actually articulated using his device. I think this project is important because it gives users more autonomy over their data, which is important especially with health data because it's so sensitive in nature. This prevents their data from being stolen by malicious actors and prevents it from being misused by like centralized servers. So I think this project kind of puts the data back into the user's hands and allows them to do with it as they please and safeguards it better for them.
The real benefit is demonstrating long-term daily use, so that way you can infer the activity of a person after some sort of stroke or other kind of cerebral vascular accident that they need to monitor their daily motions over a longer period of time and determine whether or not they are performing motions that they are supposed to be doing during their rehabilitation and therapy time.